For pretty much all of human history, progress was measured in millennia. These days, it feels like it's measured in months. So today, we're going to explore that incredible journey, how we went from just sharpening stones by hand to being on the very edge of building things one single atom at a time. I mean, just look at this timeline. It really says it all, doesn't it? For 2.6 million years, everything we made was driven by human hands. And then, bam! In what is just a blink of an eye, historically speaking, everything changed. We got power, then precision, then automation. The speed of innovation isn't just picking up, it's absolutely exploding. So that's the big question, right? How in the world did we get here? How did we leap from a pace that was measured in ice ages to one that's measured in software updates? Well, the answer really lies in four huge, revolutionary leaps forward. Okay, let's start at the very beginning, with the longest era by far, the age of the hand. This is where it all started, an age defined by human skill, by pure muscle, and honestly, a truly epic amount of time. Yeah, you're seeing that right. And nope, it's not a typo. 2.6 million years. For the vast, vast majority of our time on this planet, this was the speed of progress. Innovation wasn't about the next financial quarter, it was about, the next ice age. So, the whole journey begins right here, with the absolute basics. You've got the Oldowan culture 2.6 million years ago, and their goal was incredibly simple. Take one rock, smash it against another rock, and try to get a sharp edge. That's it. That was the very first technology, the foundation for literally everything that came after. Now, I want you to really think about this for a second. It took 1 million years to get from a simple sharpened rock to this, the Acheulean hand axe. It's symmetrical, it's balanced, it's just remarkably efficient. This wasn't just another tool. It was a perfected design, a piece of tech so incredibly successful that it stayed on top for another 1 million years. And then, every once in a while, you see these incredible flashes of pure brilliance. What you're looking at is an ivory stopper found in France from 30,000 years ago. And yes, you're seeing that right. That is a hand-carved screw thread, an invention we think of as modern, figured out by someone in the Stone Age, probably just to seal a water skin. It's just a stunning reminder that the ingenuity was always there, waiting for the right moment to be unlocked. So, for millions of years, the only real power source was muscle. The first truly massive leap forward happened when we finally figured out how to move beyond our own bodies. And that, of course, kicked off the Industrial Revolution. And this was the fundamental shift that changed everything. We moved from the cottage industry, where people worked from their own homes, to the giant, centralized factory. Steam engines, pioneered by folks like Newcomen and Watt, could suddenly do the work of hundreds of people, all in one place. It didn't just change production, it completely reshaped society itself. And the impact on the world? It was absolutely staggering. In a little over 100 years, the global balance of economic power just completely flipped on its head. The nations that industrialized, places in Europe and the United States, started to dominate global manufacturing. So harnessing power didn't just change how we made things, it literally redrew the map of the world. Okay, so having all this power created a brand new problem. You could make a lot of things, and you could make them fast, but you couldn't make them all exactly the same. So to build the complex machines of the modern world, like guns and cars, we needed another revolution, a revolution in precision. This right here is the key idea that changes the game. Before this, every single part of a machine had to be hand-filed and custom-fitted by a master craftsman. If a part broke, well, you'd have to find another master to make a whole new one from scratch. But the idea of interchangeable parts, which was really pushed by firearms makers, meant you could make 1,000 triggers that would fit 1,000 different guns, perfectly every single time. It was the birth of real mass production. Now, this didn't happen overnight. It took pioneers like John Wilkinson, whose boring machine could create steam cylinders so precise that they made engines way more efficient. And it took Henry Maudslay, whose lathe finally made it possible to standardize something as simple as a screw thread. All these innovations together built what became known as the American system, a whole new philosophy where the machines themselves guaranteed a perfect fit, not just the craftsman's eye. So let's recap. We've got power, we've got precision. What's the next logical step? Well, it's giving the machines a set of instructions, teaching them how to do complex jobs all on their own. This is the dawn of automation. What's so wild is how this revolution started. It was completely analog. Back in the 1940s, making complex curves for things like aircraft parts was a huge headache. But this guy, John T. Parsons, had a breakthrough idea. What if you could feed a machine a set of coordinates, just point by point? So they literally encoded those coordinates as holes on a long paper tape. It worked kind of like a player piano, and the machine would just follow along. That was the very first numerically controlled, or NC, machine. Of course, the paper tape was just the beginning. The real game changer, as you probably guessed, was the computer. When we replaced the tape with software, we got CNC, Computer Numerical Control. All of a sudden, a designer could create a part on a screen and send that digital file straight to the machine. The whole process became faster, way more flexible, and just immensely more powerful. So let's just take a step back. We've gone from chipping rocks by hand to machines that can follow digital instructions with microscopic precision. Where does a trajectory like that even lead? I mean, what is the absolute final limit of making things? So what is the ultimate end game here? For millions of years, manufacturing has always been a subtractive process. We start with a block of wood or metal, and we cut away everything we don't want. But what if? What if we could do the exact opposite? Well, that's where this idea of molecular manufacturing comes in. You can think of it as the ultimate form of 3D printing. It's the theoretical end of the line for our journey. Instead of carving stuff away, we would build things from the bottom up, literally placing individual atoms and molecules exactly where we want them to go. And that's really the entire arc of our story, isn't it? From shaping stone, to harnessing power, to mastering precision, to automating intelligence. The next, and maybe the final frontier, is just mastering matter itself. And that leaves us with a pretty profound question. Once we can build absolutely anything we can imagine, atom by atom, what are we going to choose to make?